Oh my dear students, today we are going to start our second class of set. As you know, this class is important for all three exams of NTRO as well as Airport Authority of India's Junior Executive exam. My dear, I couldn't upload the video yesterday because my throat was not at good condition. Even I was not able to speak properly. And yeah, that is our second class. So without wasting time, let's start our class. Now here are two sets, set A and set B. Set A contains 1, 2, 3, 4. There are 4 elements in set A and there are 4 elements in set B also. Then I will say the set A is equal to set B. As we can see, all the elements of set A are same as all the elements of set B. It doesn't the order of writing the elements, it doesn't matter. We write 3 before or 1 at first place and 2 at the second place, it doesn't matter. So the main thing is that the elements must be the same, then our set will be the same and the set will be called as equal set. As I write down here, elements are same, sets are called equal set. Now come to the second example, that is set A, and the elements of set A are 1, 2, 3, and set B, the elements of set B are 2, 2, 1, 3, 3. There is a repetition of element. My dear, if there is a repetition of element, we will count it at once. There are 2, I write down 2 times, but it doesn't matter. If there are in set A, if there are 3 elements 1, 2 and 3, in set B, we will just look at that what are the elements of set B. We didn't consider the repetition as 2, 1 and 3. Then I will say there are 3 elements in set B. One element is 2 and second is 1 and 3. And my dear, set A will be equal to set B. Now come to the next topic, next concept. Here you see that this is a set builder form of a set. A set is written in set builder form. My dear, whenever x is written as between these symbols, greater than or greater than, then what will the meaning of this? It means x is in between A and B. X is in between A and B, but x value cannot be A or B. Then it will be said as open interval. My dear, keep in mind the value of x will never be equal to A and B. Now come to the second. Here we can see this is also an open interval, but the value of x can be equal to A. X lies between A and B, and x value cannot be B, but x can be equal to A. And we will say it open interval including A, open interval including A and excluding B. So as I said to you, x can be equal to A but cannot be equal to B. Now come to the next. Here we can see another set builder form of a set. It is also an open interval including V. The value of x can be B but cannot be A. That's why I said excluding A and including V. Now come to the next. Here we can see the value of x can be A as well as B. That's why we said it as a closed interval. In closed interval, the value of x can be A as well as B. So this is called closed interval. Now come to the next point. There is a set A and the elements of set A are 1 and 2. Then my dear, can I write the subsets of A? Yeah, I can write. And I know that this is an empty set. Empty set is a subset of every set. I am repeating, keep in mind, empty set is a subset of every set, and empty set has no elements. Now there are 3 subsets of A also. I can write 3 subset of A also. One subset is containing element A, element 1, and the second containing element 2, and the third subset containing element 1 and 2. As you can see, the elements of set A and subset of A are equal. As in our first class, I told you that every set is a subset of itself. So it is the set A is also a subset of itself. That's why I wrote this elements 1 and 2. So the total number of sets are here. We can see they are 1, 2, 3 and 4. There are 4 sets. These are 4 sets. I write down 4 subset of set A. I write down 4 subset of set A. Yes. And now, yes, my dear, focus here. Focus here. Here you see what do you see here? I write down a curly bracket, and in between I write down the all 4 subsets of A. I write down all 4 subsets of A in this tabular or roster form. Here you can see all these 4 subsets are the elements of a set, this set PA. All these 4 subsets are the elements of set PA. So I will say that it is a power set of A. My dear, power set of A contains all the elements. Power set of A contains all the subset of A as element. Once again, power set of set A contains all its subset as a element. So this is how we write the power set of a set. This is there is nothing about what we can see. We can just write the first we will write the subset of a set, and then we will write a set that will contain all the subset of A, and it is called as power set. Elements are subset of set A. Yes. Now come to the next point. My dear, this is not 2, this is M. This is M. As we know, NA means number of elements in set A. If there are number of elements of set A are M, then number of subset we can made is equal to A equal to 2 to the power M. Suppose there is a set A, and how many elements are there in set A? 2 elements. Then number of subset we can write 2 to the power M Q value. What is the value of M? M equal to 2, and the value of this will be 4. So my dear, as you see that they are a 4 subset of set A. Yes. Now come to the next concept. My dear, this is a Venn diagram. Before reading this concept, we will go to the last. First we will read this. Here what you see. My dear, Venn diagram is nothing but a representation of sets and elements. As we have seen in our first class, that there was the 2 format of representing a set. One was the tabular or roster form, and second was the set builder form. And there is also another kind by which we can represent our set and elements. Here you can see here that there is a set B, and the elements of sets are 4 and 6. You can see I write down the 4 and 6 in a circle, and this is the circle B, and actually this is the set B, and set B contains 2 elements 4 and 6. Now you can see A. Actually this circle, the other circle, the larger circle represents the set A, and set A contains 2, 8, 4, 6, 10. All these elements are contained by set A, and there you can see also it contains set B. So my dear, we can say that set A contains all these elements and also a subset, that is B. B is a subset of set A, and all these elements are set A. Here you can see universal set. Universal set is always represented by a rectangle. You can see all the elements are the elements of a universal set, and all the sets, set A, set B, are the subset of universal set. So universal set contains all the sets as subset and all the elements. All the subsets and all the elements are contained by a universal set. As I write down here, all elements are elements of set U, and all sets are subset of U. Yes. Now we comes here. As you can see, there is another new concept, that is A intersection V. What is A intersection V? My dear, as you can see, this is a universal set and it contains 2 subsets, subset A and subset V, and there is a overlapping area. This is called A intersection B. Sorry. So what is the intersection B? My dear, A intersection V means the set of all x is such that x belongs to A and x belongs to B. A intersection V is a set of elements which belongs to both A and B, yes, both A and B. So the elements lying in this area will be the A intersection B. This is set A intersection V. Once again I am telling you, A intersection V is what? Intersection V is the set of all x is such that x belongs to A and x belongs to B. The elements which belongs to both A and B, that will be the A intersection B. Here you can see the example. The elements, suppose that elements of A are 1, 2 and 3 and elements of set B are 2, 3 and 4. Then what are the common elements of A and B? You can see 2 and 3. 2 and 3 are common elements of set A and set B, and the A intersection will be 2, 3. 2, 3 will lie here. Now come to the next topic. Yes, you can see this is a disjoint set. Disjoint set is nothing but A intersection V is equal to 5. If there is no intersection area, there is no common area, then the common elements are 0. There is no element in between them that is common. So we will write it as then A intersection V. The set A intersection V will be a empty set because there is nothing in between common between two sets. As we can see, for example, set A, elements of set A are 1 and 2 and elements of set B are 3 and 4. There is no element is common. Nothing is common in between them. Then the set A intersection V will be a empty set. An empty set contains no element. Now we come to the A union B. A union B, my dear, what is A union B? The A union B is a set. The set of all x is such that x belongs to A or x belongs to B. For example, A contains elements 1, 2 and 3, V contains 2, 3, 4. Then A union V will be what? A union V is the set of which consists of all elements of A and all elements of V. A union, my dear, A union V will contains all elements of A and all elements of V. Here we can see the elements of A was 1, 2 and 3 and V elements of V set were 2, 3 and 4. Then A union will contains all these 6 elements. It will contain 1, it will contain 2, it will contain 3. As 2 and 3 has already included, that's why we will leave it and we will write 4. So the elements of A union B will be 1, 2, 3, 4. Okay, A union V is done, and A union V is represented by this area. This area is represented by A union B. Okay, come to the next point, that is, my dear, as you can see, this is A minus V. This is a difference, subtraction. If we subtract a set from another set, suppose there is a set A and set B and this is a intersection area, this is a common area of A and B. If we subtract B from A, then what will happen? Set of element which belongs to A but not to B. A minus V, set A minus V will contains all the elements which belongs to A but not belongs to B. My dear, we will subtract this area. This area will be subtracted. The elements lying in this area will be subtracted. So it will be A minus V. If we write down V minus A, then set of element which belongs to B, which belongs to D but not A. Then we will subtract this area. This area will be subtracted. So all these concepts we have understand, and there is a 1 or 2 concept remaining and some numericals. We will do some numericals, my dear. It will we can expect one question from here. This is a very good topic and we will do whatever the questions can come in exam. We will solve all of them, and there is within one class. After this class we will do one class of set and we will complete all the syllabus, all the concept and all the numericals of this topic. So my dear, let's meet in next class. You do your study with your passion, and yes, just meet in next class. We will meet in next class. Okay, bye.